Up to this point in differential calculus, you've used the power rule or the definition to determine the derivative of function. There are special rules that are needed or required when solving more complex derivatives. Let's consider this function y equals 2x plus 1 times x plus 3. This particular function y is expressed as the product of two linear functions, the linear function 2x plus 1 and the linear function x plus 3. Now, a lot of students believe, when they first are introduced to this topic, that to take the derivative of this particular function, it is merely a matter of taking the derivative of the first linear function and multiplying it by the derivative of the second linear function. So when you take the derivative of 2x plus 1, you obtain a 2. And when you take the derivative of x plus 3, you get 1. So they believe that y prime is the product of 2 and 1, or that y prime is equal to 2. Well, let's go back and consider that function again. Y equals 2x plus 1 times x plus 3. Let's expand that expression. So we're going to multiply the 2x plus 1 by the x plus 3 using our distributive property. You obtain y is equal to 2x squared plus 7x plus 3. Well, this is a quadratic function, and we know that you can use the power rule to find its derivative. So when we use the power rule, we obtain y prime equals 4x plus 7. We know for a fact that this is indeed the derivative of this function, based on the work we've done in the previous units. Well, obviously, this answer doesn't correspond to the derivative that we worked out previously. Y prime is not equal to 2. There's an error in our logic. In this particular lesson, we're going to find out how we can find the derivative of a function which is the product of two other functions. We know at this point that it's not merely a matter of taking the derivative of the first factor and multiplying it by the derivative of the second factor.